right, this is section 8.3, page 1, and we're going to learn about regular polygons and area. So remember from the past, we learned that regular polygons are both equilateral and equal angular. So all the sides measure the same, all the angles measure the same. So when we talk about the center of a regular polygon, we talk about it being the common center if we either inscribe or circumscribe circles with that polygon. Okay, so what is a radius? Well, a radius of a regular polygon is any line segment that joins the center of the polygon to one of its vertices. So that would be a radius. So we can label that R. And then here as well, the center to a vertex. Okay, so that's R. That's the radius. Now, it gives us some information about the radius. We're told that any radius of a regular polygon bisects the angle at the vertex to which it's drawn. So that means that this angle is equal to that angle. Okay, those are congruent angles. All right, on to an apothem. Apothem of a regular polygon is a line segment drawn from the center. So both of these start from the center, but now this one is drawn perpendicular to the side. Okay, so this is the apothem here. Okay. Any apothem of a regular polygon bisects the side to which it is drawn. So this would be perpendicular to this. Okay, these are congruent. Okay, are congruent. Okay, so how are you going to remember the difference between these, the radius and the apothem? The way I like to think of it is the apothem has a P in it, and that's the one that's perpendicular. Radius doesn't have a P in it. So when you think of apothem, think it's drawn perpendicular, and you can't draw perpendicular to a vertex. You have to draw perpendicular to a side. Okay, next definition. A central angle of a regular polygon is an angle formed by two consecutive radii. So remember, the radius goes from the center to a vertex. So if you have two in a row, another radius here, that ends up being a central angle. And we talked about that before. It uses the center as its vertex. So these would be different shapes here. These would be examples of central angles. All right, then we have a theorem that says the measure of a central angle of a regular polygon of n sides is given by, this is the measure, C equals 360 degrees divided by n. Well, let's think about that. If we go all the way around here, a circle is going to give us 360 degrees. So if we have n sides, how many of these angles would we form? Well, let's try on the triangle. If we go here and do the next one, we would have how many? 3 sides also gives us 3 central angles. So each one of these, we take 360 and divide by 3, and we'd find those would be 120. So let's make sure it works here. How many central angles would we get here? Well, if we draw one to each one of the vertices, we can see that we get 1, 2, 3, 4, 5 central angles as well as 5 sides. So any one of these is going to be 360 divvied up by 5 different angles. So 360 over 5. All right, that concludes page 1.